Welcome everybody. We got this question. We are expected to solve this. So what I wish to do foremost is to utilize this formula that cos2x is equal to cos squared x negative sin squared x. So this is equal to integral root of cos squared x negative sin squared x divided by, now you have a sin x dx. What I would do is I would bring this inside the square root. So this is going to be cos squared x negative sin squared x. I will draw the root to cover the denominator and write this as sin squared x dx. Now this is rewritten as root of cos squared x over sin squared x negative sin squared x over sin squared x times the dx. Now cos x over sin x is equal to cot x. So this means this is root of cos squared x, sin squared x can be cancelled. So this is what we got. Now let me take cot x is equal to secant theta. This is a substitution we are doing. So when you differentiate cot x, you will get cosecant squared x dx with a negative sign. When you differentiate secant theta, you will get secant theta tan theta d theta. So from here dx is equal to secant theta tan theta d theta divided by cosecant squared x. Now there is a formula. Cosecant squared x negative cot squared x is equal to 1. So cosecant squared x is equal to 1 positive cot squared x. So utilizing this formula, this is going to be, there is a negative sign here. So let me place the negative sign there. So negative secant theta tan theta divided by, in place of cosecant squared x, I would be writing it as 1 positive cot squared x. Now this is equal to negative secant theta tan theta d theta divided by cot x is secant. So this is 1 positive secant squared theta. This is what we've got. So in place of dx, we substitute this. So go back to, probably I'll write this as 1. So therefore 1 can be rewritten as root of, in place of cot x, you place secant squared theta negative 1. In place of dx, you have a negative sign. So place a negative sign. And this is secant theta tan theta d theta divided by 1 positive secant squared theta. Now what you got to do is you convert everything to sine and cos. Okay, convert to sine and cos. So I'm going to the next side so that I can have this in the frame. Now what is secant theta? Secant theta is 1 over cos theta. What is tan theta? Sin theta over cos theta. So this is equal to integral root of 1 over cos squared theta negative 1 over cos theta sin theta or cos theta divided by, in place of secant is going to be 1 over cos squared theta times d theta. So this is what we have got. So now you have to simplify. So this is equal to negative root of, now I want to write this as with the cos squared theta denominator. So that will give me 1 negative cos squared theta. The root is going all the way down. Multiplied with, I can multiply these two together, sin theta over cos square theta. Now this one can be taken as LCM, and cos square theta will come to the numerator, and this will be cos square theta positive 1 times the d theta. Now cos and the cos gets cancelled. Now 1 negative cos square theta is sin square theta. It's a trigonometric identity. So it's equal to negative root of sin square theta divided by root of cos square theta, that is cos theta, multiplied with sin theta divided by 1 positive cos square theta. So I would say we have got sin theta with the square root will be removed. So you have sin theta there divided by cos theta multiplied with 1 positive cos square theta. You already have another sin theta times d theta. Okay, so sin theta can be multiplied. You get sin square theta divided by cos theta times 1 positive cos square theta. Now, as I mentioned to you, we have this trigonometric identity for sin square theta. So move that in. So this is 1 minus cos square theta divided by cos theta times 1 positive cos square theta. Now I want to get rid of this this cos square theta. So what I wish to do is I will actually write the quantity as 1 positive cos square theta. I need to get a negative cos square theta, right? So 1 positive from cos square theta, you take away 2 cos square theta. So if you were to take away 2 from cos square theta, you take away 2 cos square theta, you are ending up with negative cos square theta. So there is no harm in that, right? So this is divided by cos theta times 1 positive cos square theta times d theta with a negative sign. So this is equal to, I'm going to rewrite this, let the negative sign be out. So I'm going to be rewriting this as 1 positive cos square theta times d theta divided by cos theta times 1 positive cos square theta negative 2 times integral cos square theta divided by cos theta times 1 positive cos square theta times d theta. Okay, this is what we have got. Is there any deductions can we get in to? Okay, so now you see here 1 positive cos square theta, 1 positive cos square theta can be cancelled. So this is going to give you negative parenthesis integral d theta over cos theta, negative 2 times a cos and a cos gets cancelled, giving you cos theta divided by, now this is cos square theta. It will be much better if I have a sine. So again I will be utilizing this identity. So from here I can rewrite this as cos square theta is equal to 1 negative sin square theta, isn't it? So if I were to rewrite that as 1 negative sin square theta, this would become 2 negative sin square theta. Is it not? Fair enough, right? So all of these things has to be closed because this minus sign is actually leading. Now having given you this, let me just move it. So we have to consider 2. I'm just going to utilize this side of the page. Now this is d theta over cos theta. You consider this first. Consider d theta over cos theta. Now what is d theta? What is 1 over cos theta? That is secant theta. So if you were to integrate this, you get ln modulus secant theta plus tan theta plus c. That's a formula, standard formula. Next comes to integrate cos theta divided by 2 negative sin square theta times d theta. So what I will do, I will take let sin theta be equal to some t. This will be cos theta d theta is equal to dt. So you substitute this. So this is going to be, in place of cos theta d theta, it is dt in place of sin theta, it is going to be t squared. Now this is similar to dx divided by a squared negative x squared, which is nothing but 1 over 2a ln modulus of a positive x divided by a negative x plus c. This is the formula. So this can be rewritten as integral dt divided by, this is a standard formula by the way, and you can refer to my previous notes, I have proved it. So I'm going to rewrite this as root of 2 squared negative t squared, which is equal to 1 over 2 times of a is root of 2 ln modulus of root of 2 plus t over, you have to add root of 2 minus t. Okay, fair enough. Now what is my value of t? Is sin theta. So this is going to be 1 over 2 times root 2 ln modulus of root of 2 positive, my t is sin theta, so place the sin theta, divided by root of t negative divided by root of 2 negative sin theta. Sin theta should come there. Okay, fair enough. Now we need to take these two components and place it here. Okay, I'm going to take this as 2. We have to take the two quantities and we have to place it here. So let me do that. So this is equal to negative sign is there for the first component. The first one we already have that. What is that? Ln modulus secant theta plus tan theta. Fair enough. For the second one there is a negative sign and a 2 there, and you have to place this one here. So that is going to be 1 over 2 times root of 2 ln modulus root of 2 positive sin theta divided by root of 2 negative sin theta. Okay, now this has to be covered with the entire parenthesis. I'm not going to place any c now. Now distribute this negative sign. So this is going to be negative ln modulus secant theta positive tan theta positive 2 and 2 can be cancelled, right? This 2 and this 2 can be cancelled. So you're going to have 1 over root 2. I will rewrite it again. 1 over root 2 times ln modulus root of 2 positive sin theta divided by root of 2 negative sin theta. Now this is what you got. Now what is the substitution you made? You took a substitution as cot x is equal to secant theta. You have to bring that back here. Now since cot x is equal to secant theta, now what is the meaning of this? This means we will have to somehow extract the representation for sin theta, right? Sin has to come there. So this means cot x is equal to 1 over cos theta. So this means cos theta is equal to 1 over cot x. So this in turn means cos theta is equal to tan x. Now I square both sides. Now as I mentioned to you, there is an identity for cos squared theta. That's nothing but 1 over sin squared theta is equal to tan squared x. Now bring this tan squared x, move this sin squared x to the other side. So this is going to give me 1 negative tan squared x is equal to sin squared theta. We need only sin theta. So this means sin theta is equal to root of 1 negative tan squared x. So you have to bring this. You got to work this out and you have to bring it. So I'm going to take this as 3 and I will rewrite it on this page. So therefore 3 can be rewritten as, so secant theta, as I mentioned to you, this is going to be negative ln modulus. In place of secant theta you place cot x plus tan is I have to bring in this tan. Now tan is let me write down here. Now tan square theta is secant square theta minus 1. So therefore tan theta is equal to root of secant square theta minus 1. So this is equal to root of secant theta. Secant theta is cot x. So this is going to be cos square x minus 1 is equal to tan theta. So we have to substitute that. So let me substitute that, plus root of cos square x negative 1. Okay, fair enough, that is done. plus 1 over root 2 of ln modulus root of 2 positive. As I mentioned to you, sine theta is root of 1 negative tan squared x. So this is root of 1 negative tan squared x divided by root of 2 negative root of 1 negative tan squared x plus arbitrary constant c. Okay, please check. This is what we got. So this is all for the working. So this is the end of this question. So let me show you the question. So this is the question. So we started like this, okay, and then we simplified like this, and then from here we have to integrate these two. So I perform the integration here, and then we have to revert back. So this is the reversion, and then this is the final solution. So you have to practice these things. Okay, I have scaffolded it, but with the consistent practice you will be able to clock a better time, right? So speed is also important. Efficiency and speed matters a lot. So please like, share and subscribe. Thank you.